Good evening, guys. I'm gonna go over the this review of this exam really quick, so you can have an idea how this is gonna be done, or just to give you a brief idea how you're supposed to solve these problems, right? Um, as you can see, this is the structure of the test. So that's how I will basically give you the test on Thursday, right? Okay, so let's start really quick. I'm gonna try to divide this video into sections, so it's not gonna be that long. So you can, I'm gonna try to do part one and part two, so it's not gonna cover like 1 hour or whatever, right? So the linear correlation coefficient of a data set, or I'm sorry, the linear correlation coefficient of a set of a data was calculated to be negative 0.8988. This number indicates that the data has positive linear correlation, no correlation at all, perfect negative correlation, strong negative correlation. So you know in your textbook, I believe they said that strong correlation should be between 0.8 and 1, right? And I believe some moderate will be between, or like a low, it will be a low, the correlation will be not strong if it's between 0 and 0.5, right? So this applies also for negative values, right? So I can say this, right? So so therefore, this correlation coefficient is a strong negative correlator, right? So the answer in this case will be strong negative correlation, right? Okay, so that's the answer for that problem. So that's straightforward. Which of the following measures cannot be measured, or cannot be a measure of variability of the data set? So that's straightforward too. You know that the standard deviation, the variance, and the range are measures of variability. So it should be this guy, right? The mean, right? The mean doesn't measure variability. Next, a numerical value whose measured value can change from one replicate of the experiment to another. So this is the same thing as a random variable, right? We talk about this many times, right? If you measured the thin Cooper wire that I put here, right? You're trying to measure the current, right? If you measure that one time, it's gonna give you a numerical amount. That the second time, that numerical amount is gonna be the same. It's gonna change, right? From the first time, from the second time, from the third time, and that's what we call variability, right? But in this case, that's a random variable. We call random variable because every time we trying to measure it, the value that we get is different, right? So this is what a random variable, or I'm sorry, a random value here. Okay, the relationship between the number of miles driven and the amount of gasoline used. So I think it would make sense to say, well, the more miles I drive, the more gasoline I will consume, right? Therefore, there's when one variable goes up, then the other variable goes up as well, right? So let's say that this is miles, right? And this is gas, right? So as one goes up, as you drive more miles, you will use more gas. Therefore, there's a positive correlation here. However, correlation that does not imply cause and effect or causation, right? But in this case, right, it's not always a correlation cause causation, right? But in this case, I would say this situation will give you a cause and effect situation, right? Because these two variables are highly correlated, right? Intuitively, you can think about the more miles you drive, the more gas you will spend, right? But also, it makes sense that this is a cause and effect situation, right? Because if I drive more, I will spend more gas, right? So in this case, there's a cause and effect. So and it also there's a correlation. So it should be both correlated and causal, right? So because you there's these two variables, as one goes up, the other one goes up. So they both are highly correlated or positive correlated, and also there's a cause and effect. So then that would be the answer for that. 5. A study of an experiment where the conclusions are to be drawn relatively to the future population is called. So we talk about this, right? When we study, well, this is the definition of what? This is the definition of analytical study, right? We talk about that in class. An analytical study is just when we're trying to draw conclusions about a future population, right? That's what we talk about in class many times. And if you look at your textbook, that's the definition that they give for analytical study. Okay, so I think those are the 10 questions from the multiple choice. So I think it's very straightforward. Yeah, so let's do this. This is also straightforward, I believe. So let's go here down on the bottom. And they want you to find the following data represents the number of hospitals for selected states. So they give you all these values. Let's count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now, if you do this by hand, it's going to take you some time, right? So I told you in last class that you have to bring your calculator. So I'm gonna show you how to use the calculator, and I'm gonna put these values in a calculator, right? Just bear with me. Give me 1 second. Okay, so I believe you should be able to see what's going on. Let me make it bigger. Let me see if I can make this bigger. I don't know if you are able to see my screen. I think you can see my screen. Let me make this bigger. Okay, so let's turn this on. And I need to plug the values, right? So you press stats, you press enter here where it says edit. So you need to plug your values here, right? So let me clear this, and you can just introduce or type your values, right? 53, 84, 28, 78, 35, 111. We have 40. We have 40. Give me 1 second. Let me delete this one. We have 40. Then we have 166. Then we have 108. Then we have 60. And 123. Then we have 87. Then we have 84. Then we have 74, 80, and 62, right? Okay, so you have your data. Now, if you want to arrange this in order, it might help you to solve other problems, especially when you're doing the stem and leaf and this kind of stuff. So you go to stats and you go sort 8, and you put a second L1, which is where you plug your data. And now it says down, right? So now all your data set is in order, right? So if you go to stats, you press enter. As you can see now, everything is in order, right? From in ascending order, right? From lowest to highest numbers, right? So now you don't need to worry about that for this problem, right? However, it's good practice to do that, right? So it's easy for you to calculate these values. So now I'm gonna go back to the, actually, let me finish this, right? So they want you to find the mean, the mode, the median, the variance, and the standard deviation. So you can do this from your calculator. Since this is a sample, right? Let's calculate this. So you go to stats, you go where it says calculation, 1 bar stats, you press enter, 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 calculate. So as you can see here, the mean is 79.56, or let's round it to the nearest 10. So that's going to be 79.6. Then we need to find the standard deviation, right? So the standard deviation here is the sample standard deviation, which is going to be SX, and that's 35.5. And if I scroll down, I have the median, which that's what they're looking for, right? The median is 79. Okay, you need to only, so we have the standard deviation, we have the median, we have the mean, and we just need to find the mode, which is the number that repeats the most, right? If there's such a number in this data. And let's see, what else we need to find? The variance, right? So we need to find the variance of the sample, right? And we need to find the mode. Okay. So let's see. Okay, let me go back to the, well, I can calculate this here, right? So I can second quit. So if the standard deviation is 35.5, then the variance is the square of the standard deviation. That's gonna be 35.5 square, right? That's the variance. So the variance is about 1260.25, right? And now you need to compute the mode, right? So let me share this with you really quick. 1 second. So now we just need to compute the mode, right? So the number that repeats the most, let's see if there's a mode here. So we find the variance, so we need to calculate the mode. So I see 84 twice. Let's see. I'm taking a long time because I have to do with this app. So if I have the calculator in front of me, it will be quick, right? So the mode, it's 84, right? In this case, the mode should be 84 because that's the number that repeats the most. Yeah, 84. So you're done. That's it. That's the second question, right? Okay, so now we continue. Now we have to do the third one. So I think this is straightforward. Okay, this is the third question. I think I have that here. Yeah. So I already arranged these numbers, right? You can do the same thing I did here, right? So basically, you can plug these values and then you can, well, I sort them in the calculator, and then after that, well, let me do it just in case you didn't get it the first time. Let me do it for you. Okay. So let me see. So let's see. Okay. So let's see. Okay, so I need to plug the values, right? 52, 62, 51, 50, 69, 58, 77, 66, 53, 57, 75, 56, 55, what else? 67, 73, 79, 59, 68, 65, 72, 57, 51, 63, 69, 75, 65, 53, 78, 66, and 55. Okay, so now you need to, again, if you want to, because you have to make a stem and leaf, and if you do this by hand, it's going to take you some time. So you go to stats, and then you put sort, just put L1, second, L1, and it has to set done, right? So now you go to stats, and you click enter, and you see, now you have your data all nicely from ascending order, right? From smallest to highest value, right? So you can just do your stem and leaf from there, right? So that's the stem and leaf, right? Okay. So now let's go back to the actual test. Okay. So now I already did it, right? So you should do the same on the test so you know how to do this, right? So this is the stem and leaf. I forgot to put my legend here. So I'm gonna put my legend is gonna be, this implies that this is 51 or the key, whatever you wanna put key if you want, you can put here key, right? Now, what you need to do is now you make the stem and leaf of the auto card distribution. So this is the distribution. You can see it's a skew to the right or positive skew. Now you need to find the median, right? So using the interpolation formula that they have in your textbook, this is the median, right? The median or the 50th percentile is equal to 1/2 n plus 1, right? That's what they use in your textbook. So this is 1/2. Well, we have a 30 sample size, so I'm gonna do 31 because n is 30 and 30 plus 1 is 31. So that implies that, well, I calculated before, I think, so this implies that this is 15.5, right? So this is the location, right? So I need to find the 15.5. So this is 8, 9, 10, 11, 12, 13, 14, 15. So it's between these two values, right? Between 63 and 65, right? So if you subtract the difference of those two, that is gonna give you 64, right? I'm sorry, 2, right? 65 minus 63 equals 2. And if you multiply that 2 by this decimal right here, which is 0.5, you're gonna get 1, right? So you add to your lowest number. So that means that this is 63 plus 1 equals 64, right? So this is the this is supposed to be your median, right? Or your 50th percentile. Sorry about that, I have this thing all over the place. Okay, so if you don't believe me, again, you have the data in the calculator, right? So let's do that. Let's check. So clear, you have the data already, type it. So you put stats and you press calculation, right? And you should have your median here. So your median, as you can see, 64 is the same value that I did, right? When I was doing this by hand. Okay. Sometimes you might be a little off, a little bit more, but in general, you should be close to that, to these numbers, right? Okay, so let's go back to that. And 1 second. Okay, so now I found the median, right? So now that's question. So I did part A, part B. Now you need to find a 45 percentile, right? So this is not big deal. So this is 45 over 100, right? And then you need to do your sample size plus 1, right? Which in this case is 31, right? Because 30 plus 1 is 31. So you do that. So it's 0.45 times 31, and you get 13.95. So they said find P45 for the 45 percentile, right? So you need to find that value. Okay, so that should be here, right? Somewhere in P45. Let me see, I think I did it already, so I don't need to redo it. Okay, so here it is. So if you do, that's 13.95, so we can count it, right? So 13.95, this is 8, 10, 12, 13, is between these two, right? So the difference between 62 and 59 is 3, right? So 62 minus 59 is 3. And then you multiply that by this decimal that you get here, right? So that's 3 times 0.85. And you're gonna get 2.55. So if you add the lowest value, which is the 59, plus 2.55, that will be the percentile somewhere around there. So it's 61.85 or about that, right? Let me do this calculation from scratch so you can understand how I did, okay? Just in case you're confused. Okay, so I did, so I'm looking for the 45 percentile, which is basically 0.45 times my sample size plus 1, right? So if you do that 0.45 times 31, you get 13.95. So 13.95. So this is 10, 11, 12, 13. It's between these two. So if you subtract 62 minus 59, you get 3. And then you multiply times this decimal, which is 0.95, right? So 3 times 0.95, you get 2.85. So the 45 percentile should be, you add the lowest value plus this 2.85, okay? So that's supposed to be 61.85. So that's your 45 percentile, okay? Now, if you want to be exact, right? The 90 percentile is the same story, right? You do P90 times 31, that gives you 27.9, right? So instead of counting from the beginning, right? You know that there's 30, the sample size is 30, right? So you can count from here, right? So this is 30, 29, 28, 27, right? So you should be between 27 and 28. So that's between 75 and 77, as I write it here, right? So the difference is 2, right? And you multiply that times 0.9, the decimal, and you get 1.8. 75 plus 1.8. That should give you the value of that, right? Which is going to be 76.80 something. So your 90 percentile should be equal to, well, you know, the difference between these two, I'm sorry about that. The difference between these two is 2, right? And then you multiply by 0.9, right? So 2 times 0.9, you get 1.8, and 175 plus 1.8, right? 75 plus 1.8 gives you 76.8. So that's your 90th percentile. Okay, that's what they want. Now, you need to find the last part, right? So find the percentile corresponding to a score of 63, right? So you need to find the position of 63 in this data set. So 63, you need, I mean, you can count from the beginning better, right? So this is 8, the first row, then 10, 12, 13, 12, 13, 14, 15. So this is the position 15, right? So there's 2 ways to understand this thing. You can think about the values exactly at 63, right? Because we're doing this interpolation, that should be, this is the value of 15, right? But in this case, it's going to be n minus 1, so that's going to be 14. So, so this is going to be 14 over your sample size, in this case, times 100, right? Whatever that is, right? So 14 divided by 30 times 100 is about 46.7, right? And find the percentile. So this is the percentile, right? 46.7. Okay. Now you might say, if you want, you can round it to the nearest number, right? So which is 47% or 47 percentile, if you want to put it that way. Okay. So this is the 47 percentile, right? Okay. Is there a way to show that this is true? Well, you can do the same thing, right? So if this is P47, right? Or you can say P46 if you want. It's up to you. Then you can find this number, right? So this is going to be 0.46, right, times 31, and that should give you the number that we found, which is 63, right? So 0.46 times 31, and you should get 14.26, right? So let's find that 14.26. If you want to check, you don't need to do this, right? 14, so this is 10, 12, 13, 14 and a little bit. So it's between these two numbers, right? 62 and 63. And the difference is 1. 1 times 0.26, that's 0.26. So you add to your lowest value, 62 point and change, right? 62.26. So you can see it's close to that value of 63, right? So that's the idea of that. I hope that this makes sense. Okay. Okay, that's how you do that. So I'm gonna stop here because the next part is just the 5-number summary, and then I will do the other 3 problems in the next video, which I'm gonna do it right now, but I'm just gonna divide it into 2 parts because I don't want to make it too long. Okay, thank you.